factoring quadratic trinomial. So what are we doing? We're factoring. What are we factoring? Quadratic trinomial. How are we factoring it? Using what we call AC method. All right. So a trinomial, as you all remember, hopefully, is a polynomial with three terms, right? Three terms. Now quadratic would be a quadratic trinomial would be the one with three terms, but the highest exponent is 2. So any polynomial whose highest exponent is 2, the biggest one, is called quadratic. So quadratic function is a big topic for our class, for algebra 2. But anyway, so now it's called AC. The process is called AC method because we do something with this A and a C that we have on there. So this is your general form of a quadratic trinomial. A is the number in front of x squared. C is just a number without any excess on it. B, which we all will also need, is the number in front of x. So A, B, and C, they're a bunch of numbers. They're not letters or anything. They're just numbers, positive or negative, whatever. Are we good? All right. So I guess I'll explain this to you with this example here. So example. So x squared plus 10x plus 16. All right. So we have a quadratic trinomial here. This is a trinomial, three terms. The highest power is 2, so it's quadratic. And we're about to factor this thing. All right, can somebody tell me what your A would be for this thing?
X squared.
1.
It's just 1. Remember, A, B, C are just numbers, right?
Oh yeah.
So A is the number in front of x squared, which is simply 1. Let me write C first. What is your C on this thing?
16.
16, so positive 16. And then we'll also need a B at some point. So what's your B on here?
10.
Positive 10. All right, 10. So they're all positive in this case. Sometimes you have positive, sometimes you have negative. All right. So now I want all of you to look here and then copy later on once I'm done with it. Is that fine? All right. Now the reason it's called AC method is because once we recognize our A and C, we multiply them. We multiply our C times A, right? In this case, 16 times 1.
16.
That gives me 16 positive. Make a little T chart, T table, whatever you call it. And we are we all with me? Now we're looking for two numbers. Once you figure this number out and write it up here, I'm looking for two numbers, right? I'm looking for two numbers. Those two numbers must multiply to give me positive 16. But the same two number must add up to give me this middle number, which is 10, my B. You'll get it? So I'm looking for two numbers that multiplies to give me 16, but adds up to give me the same two number must add up, combined to give me positive 10.
8 times 2.
So 8 and 2. Is that fine? So good. But let's quickly look through other possibilities here, right? So 1 times 16 also gives you 16, right? But will that add up to 10?
No.
No. So this wouldn't work. Then we have 2 and 8. 2 times 8 multiplies to 16. Will that add up to 10?
Yes.
It does, right? Now once you found your number, you don't really have to do anything else. But also another possibility would have been 4 and 4 multiplies to 16, but would it ever add up to 10? No. So you'll only find one set of number that would be working, which we've already found. So once you find your numbers, everybody good with that? You go back to your problem, you copy the first term, you copy the last term, just the way they were. And we are going to break this middle term, which is 10x, right? We're not going to write 10x anymore. Instead, we're going to write that as these two numbers. So instead of writing plus 10x, we'll write plus 2x and plus 8x. Everybody fine with that? So positive 2x plus 8x is 10x anyway. We're not changing anything. We're just changing the look of the problem, right? Is that fine?
Yes, sir.
So we also went from a trinomial to 4-term polynomial. So that now what we can do here
Let's group it.
is factor by grouping. Perfect. Now we can do factor by grouping here. So you take 2 at a time. So first 2. What do they have in common? What pulls out?
X.
So x pulls out, and then what are we left with? So x comes out. So the first term, the very first one is x squared. There were 2 x's, right?
Is it 1 squared?
One of the x is gone.
Yeah.
So you have 1x in there.
Oh, yeah.
Plus, and then 2 is in here. That x is gone, but 2 never left, right? Plus, and then you do the same thing, plus because there is a plus right here, so you basically drop that down. So then the last 2, what pulls out from the last 2?
8.
8. So 8 is the biggest number that divides 8 and 16 without leaving a remainder, your GCF. And then what am I left with?
X plus 2.
So x plus, and then 16 divided by 8 is 2. And also remember, for grouping to work, this parenthesis and that must be identical. We have talked about that, right? And then what is the very next thing? So what is in common?
X plus 2.
X plus 2 comes in its own parenthesis. Then what goes on the other parenthesis?
8.
X plus 8.
X plus 8. And that is how you factor a quadratic trinomial. Are we good?
Yes, sir.
These things down here are called factors. So we have 2 factors for this polynomial or that trinomial, whatever, quadratic trinomial. Is that fine? Good? Good?
Action.
15 times 1 is 15, right? So your C times A. C is 15, A is 1. We need 2 numbers that multiplies to 15, but also add up to 8. The numbers are 3 and 5, 5 and 3, either way, same thing. Then you copy the first, copy the last, and you break the middle one into those 2 numbers, which is positive. They're both positive, so positive 5x, positive 3x. Now once we have 4 terms, we can do factor by grouping, right? So what comes out from the first 2? X. What stays in? X plus a 5, plus, because of that plus here. Then from the last 2, you take 3 out, and you have x plus 15 divided by 3 is 5. 3 times 5 is 15, either way, however you look at it. And then you have x plus a 5, which is these, right? On your second parenthesis, you write whatever you didn't write over here, x and a plus 3. Are we good? Now that is the answer. Some of you may have that as your answer, which is equally correct. So order does not matter for multiplication, right? So they're both good. All right, cool. Well, what's your A?
1.
1. What's your C?
12.
35.
35. They're both positive.
Whoa.
Your B is
Negative 12.
negative and then
Yes.
12. So that's your B. We need that B at some point.
Double wrong.
We good? So C times A times C. 1 times 35 is 35. Now I'm looking for 2 numbers that multiplies to positive 35, but also gives me negative 12 when you were to combine them, right? For 2 numbers to give me a positive product and a negative sum, those two numbers must be negative. Does that make sense?
7, -5.
So -7 and -5, because if they're both positive, then yes, it will give me a 35, but 7 and 5 add up to positive 12, right? Now if I only make one of these negative, then it gives me -35, which is not what I want anyway. So you make both of these negative. So you copy the first, you copy the last, you break the middle one into those two numbers. So -7 with x, -5 with x. And then we do factor by grouping. What comes out from the first two?
X.
X. What stays in is x minus a 7 minus, because there is a minus, what comes out from the last two?
5.
5. What stays in
X.
is x.
7 plus 7.
Well,
Minus.
remember they have to match,
Oh,
right?
minus
So
7.
35 divided by -5 is -7. So you have x minus 7, x minus 5. So these are your two factors, right? Of this thing. Anybody has any question on this? Okay. Alright, so another. Now, what is my A on here? 2. Alright. My C is 15 and B is 11. Now, because my A is 2, can I do a shortcut? No. But, no worries, the process is the same. So you take your C, multiply with your A. So 15 times 2
13.
is 30, positive. We are then looking for two numbers that multiplies to positive 30, but the same two number would add up to positive 11.
6 and 5.
6 and 5. Positive 6, positive 5. 6 times 5 is 30. 6 plus 5 is 11. Is everybody okay with that? Okay, then we copy the first term, which is 2x squared. We copy the last term, which is 15 plus 15. Don't write 30, it's, last term is 15. Then we break the middle one into these two numbers. All right. Now, please listen here. So, does it matter whether I put 6 first or 5 first? Well, the answer to that is no, it doesn't matter. You can put positive 5 first, 6 next, or the other way. However, it may, for some of you, make it easier to put certain number in certain order. Does that make sense? So look at this. One of my number is 6, right? Does 2 go with 6 more or 5? Does 2 go with 6 or 5? 6. 2 and 6 have something in common, right? So if you put that number 6 next to 2, it might make it a little easier for you to get to your factors, at least at this stage of learning. Then the next number is plus 5x. Now the order does not matter though. And then you do grouping. The first two, what comes out from the first two?
2.
2. What else comes out? X. 2x comes out. What are we left with?
X plus 3.
X plus a 3. Is everybody fine with that? Then plus, because of that plus, what comes out from the last two?
X plus 3. Oh, 5.
5 comes out. 5 is the biggest number. That divides 5 and 15 without leaving a remainder. Then you have x plus 15 divided by 5 is 3. And then at the end, you would have x plus a 3, 2x plus a 5, and these are your factors. Is that fine? Okay, cool. All right, -3 times 2 is -6. Two numbers that multiplies to -6 but add up to -5.
-6 times 1.
So -6 times 1. Cool. So you copy the first, you copy the last. You need to keep up with these y's as well. Break this into these two numbers. Because I see a 6 and a 2, I would put them probably together, 6xy negative, and then plus 1xy, positive 1, negative 6xy, right? Are we good? And then factor by grouping. So what comes out from the first two? So 2 comes out, but they both also have x in common, so x comes out, right? And we're left with 1x from here, minus, well, 6 divided by 2 is 3, y, and then plus, then what comes out from D?
One.
Y.
Or Y.
So just y, they both have y in common, so y comes out, and you're left with x, minus 3, and then 1 of the y, and then you have x minus 3y, right? And then you have 2x plus a y. And these are the factors. We good?